What are we going to be doing today? We're going to be working with limits at infinity to discover horizontal and vertical asymptotes. And so basically a lot of what we're doing right now today is going to feel a little bit like review, I hope. The only difference between what you would have done in pre-calc and what we're going to do now is we're going to actually be able to identify without having to like sit there and try and do a bunch of stuff that feels like magic. We're actually gonna be able to work with numbers and talk about how stuff happens. So I want to start with this right here. So back in pre-calc, you would have gone through, you would have, in order to figure out what the horizontal asymptote was, which is what we're doing, is you would have had to rewrite this in some sort of rational form, and then you would have had to look at the top of the function versus the bottom of the function, compare the degrees, and yada 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 yada. You don't have to do that anymore, because what we're going to do is we're going to say, all right, well, let's see what f of x is as we go to infinity. So what we're going to do is we're going to take this and we're going to take x and we're going to make it, basically make it infinity. We're going to approach infinity. We can't make it infinity because infinity is not a number, but we're going to make whatever's in the denominator humongous, so that 5 divided by that humongous number is basically just 0. So this is 0, right? And so what's left over is this constant. So as x gets super duper 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 big, this fraction part tends to 0. And what's left over is this minus 7. So the answer is just minus 7. Now let's look at what happens. So this is when it goes to positive infinity. Let's do the same thing with negative infinity. Well, doesn't matter if the big number is positive or negative, this is still going to be 0, right? Minus 7. So 0 minus 7 is still going to be negative 7. So it doesn't matter if it's going to positive infinity or negative infinity. It's just negative 7. And this is what we mean when we're talking about a horizontal asymptote, right? This is what we actually mean. If we look at the function, here's my terrible graph here, but if we look at the function, as we go to positive infinity, the y value approaches negative 7. As we go to negative infinity, actually, I think that's supposed to be flipped. Is it? No. Yeah, there we go. Yeah, so what this does, as we go to infinity, we know that it approaches negative 7. As it goes to positive infinity, it also approaches negative 7. That's how we know what we have here is a horizontal asymptote, is that if we go and we see the infinity and the negative infinity limits approaching the same thing, we know that's a horizontal asymptote. The vertical asymptote, we know by looking at the denominator here, is 0. And that's how we know what the vertical asymptote is. So as we keep going, we're going to be doing the same sort of thing. So once again, we're going to make x go to infinity and negative infinity. Now, this looks really, really weird, but I'm going to tell you the way that it's written like this makes it very easy. Because look, 1 over x, when x is infinity, 1 over a really big number is basically 0. So when we're looking at this, we're really looking at 2 over 11 plus 0, which is 2 over 11. And it doesn't matter if that going to 0 is coming from positive or coming from negative. 0 is 0. And so as x goes to infinity, we get 2 over 11. And as x goes to negative infinity, just because it's plus 0 versus minus 0, this is still going to be 2 over 11. So don't feel like it's going to be any different. All right. Now with this next one, as we're going through, again, we're going to make x go to infinity. So what we're really trying to look at is this part, right? And this part. So let's look. Again, when I plug in infinity, when I plug in a really, really, really big number for x, this top just becomes -2, doesn't it? And then when I plug in infinity, when I plug in a really, 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 really big number down here, this fraction becomes 0, and so we're just left with 6. So what do we really have here as x approaches both infinity and negative infinity? -2 over 6, which simplifies to -1/3. Again, these are not meant to be difficult. These are meant for you to push through and take 2 seconds to do. If you're coming towards a number, you know that you're good with this. All right, for this next one. So what causes confusion here is how does the sine function behave, right? Now, if you remember from trig, the sine function, as x gets bigger and bigger, doesn't grow. It stays between 1 and -1. So really, this part is basically just a constant. Because this denominator is going to get super duper 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 big. Nobody cares about the sine of 3x. It ain't going to grow very far. It's going to go between -1 and 1. So the only thing we really care about is what's down here. And really, so what we have basically at its biggest is 1 over infinity, right? And again, what we said was this is 0. So sine, this is for sine and cosine. Sine and cosine disappear when you go to infinity land. They don't have any growth that helps them compare to stuff like a polynomial function. So like if something's growing bigger, we can basically pretend like the sine's not there, if that makes any sense. All right, now take a look at this one. X is getting bigger and bigger and bigger and bigger. So the thing of it is, if you look at these numbers right here, this 2 and this 3, they are not getting bigger. When x gets super duper 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 big, this 2 and this 3 are basically ignorable. So in infinity land, we only care about the leading terms. So what's really going to happen here is this, as x approaches infinity, f of x approaches this. The other terms there don't matter. They don't grow anywhere near as quick. And by the time x gets to be super duper big, they're negligible. They don't matter anymore. So really, we're looking at that as our final answer because the x's cancel out from each other, right? That common factor of x. So in infinity land, when we've got a numerator and a denominator we have to compare, the only thing you have to compare is the thing that grows the fastest. Like this. Again, there's a lot of stuff going on here. The first thing we should do is rewrite it in terms of how fast things grow. So I'm going to rewrite this before we go to infinity land. the t term grows the quickest. The sine kinda, and then we've got the 5t. This one's already in order. So the first thing we can do is we can identify the things that aren't going to follow us to infinity land. They don't grow, or they don't grow fast. So 2, you're out. Sine and cosine, you're out. So what are we left with? As we approach infinity, we're left with this. So look at this. The t's cancel out, and we're just left with -7 over 5. Let's do some more. Once again, same concept, right? We're going to go to infinity land. Now, we know that this 5 and this 2 are not going to follow us because they're constants. But now look at this stuff extra down here. Is x to the first going to grow anywhere near as big as x to the fifth? Heck no. Even x to the third is not going to grow very fast. All we care about is those leading terms. These parts don't grow fast enough. They're not going to follow us to infinity land. They're not big enough. We just care about the terms that have the highest degree on top and the term that has the highest degree on bottom. So 4x to the fifth. I shouldn't put an equal sign because that's not true. They're not equal. It's as x goes to infinity, f of x goes to, and again, you look, the x to the fifth on top, the x to the fifth on bottom, they cancel out. This is just the number 4. Same thing going the other way. Again, if you've got here's what I'll show you. This is what's really happening, right? This is negative. And what happens with the negative over a negative is a positive. So either way, it's still 4. Here, if it was positive infinity, those positives are still positive, leaving us with 4. For both of these, as long as the negative signs cancel out, you're left with the same thing with the positive. All right, let's do another one. Again, same idea. What are we going to do? We're going to follow this to infinity land. As x goes to infinity, this is going to travel to infinity land. The 10 and the 16 are not big enough. They don't follow. So what are we left with? We're left with x squared over x cubed. Now we simplify our fraction to 1 over x. And now we're back to what we started with. When we go to infinity, and there's an x in the denominator like that, this goes to 0. Same thing with negative infinity. Goes to negative big number. 1 divided by any kind of big number is still going to be 0. All right? So if you can break it down to something like this, you know it's going to be much, much easier to work with. Let's do some more. All right, so now here we go. We're going to follow this to infinity. So this is going to go to, we're going to get rid of all the things but the leading terms. And we're going to simplify our fraction. We get that. Now, as x gets bigger, does this stay the same or does that go to 0? No. This actually goes to infinity. Now, we would say this limit diverges. Even though infinity is our target, like what as x goes to infinity with the limit, what does the function go to? What's the limit of the function? Infinity. What's the limit of the function as x goes to negative infinity? Goes to negative infinity. But I want to talk about the fact that the number that we got in the number. Infinity is not a number, right? Infinity is a concept. We don't ever actually get there, yada, yada, yada. But like, so one of the things to note on your homework is the answer you're going to give. What is the value of this limit? Infinity, negative infinity. You'll actually type that in. There'll be a little button you can click on for the infinity symbol. But I want to talk about the fact that we say that this limit diverges. This limit has no number that's associated with it, not like 5 or 3/2 or whatever. The limit approaches infinity, and so we say it diverges. We're going to use that terminology here. The limit diverges. On the AP exam, you could say this limit diverges to infinity. It goes to infinity, but the key is that we want to talk about the fact that it doesn't hit upon just some kind of whole number. It doesn't hit upon like a target number. Like all the rest of these absolutely did. We got 0. 0 is just a number, right? We got all these different possibilities. 4, that's just a number, right? But when we're talking about this one, if it goes to infinity, if the limit approaches infinity, even though the limit has a target, it went to a place, it went to infinity, that's not a number. You get what I'm saying? So just be aware of it. It's not a number, so we don't want to say that like the limit value is infinity. That doesn't make sense. Infinity is not a value. So just be aware. Now take a look at this one. This one's really nifty. Because again, what we're going to do is we're going to go to infinity land with this whole thing. And we're going to remind ourselves that 5 and 1 don't follow us there. We only want the biggest exponent. So look at what this becomes. As x goes to infinity, this goes to the 4th root of 81x to the 5th over x to the 5th. Well, now can't we just cancel out those x to the 5ths? But doesn't this basically equal 81? And what's the fourth root of 81? What number times itself 4 times is 81? Well, that's 3 times 3 times 3 times 3 is 81. So this approaches the number 3. So look at what we did. We canceled out the parts that aren't going to follow us to infinity land. We got this going on, right? And then we simplified our fraction, and then we actually solved it. Do another one. And this is the same idea here. And again, we're going to look at these things here. This radical x, it helps us to rewrite this whole thing in exponential form. Radical x is the same thing as x to the 1/2, right? You know, maybe you want to write 4x to the 1. That's fine. You don't have to. But again, we're going to take this, we're going to take the limit as x goes to infinity. And so this is going to approach, well, let's get rid of the smaller x terms. This -5th, that's not as big as 1/2. We can just get rid of that. This doesn't even have an x, so that's not going to go anywhere. This is what we're looking at, right? So let's look. We got 8/4. We can even simplify that if we want to. We've got 2 x to the 1/2 over x. And then we have to simplify this 1/2 x to the 1/2 over 1, right? Over x to the first. So let's do that. Well, if we're going to do that, we have to remember how to simplify these things, right? We subtract the top one from the bottom one. If it's a negative, we put it on the bottom. If it's a positive, we put it back on top. 1/2 minus 1, well, that's a -1/2, right? And notice -1/2, so I put the 1/2 on the bottom. Well, now, once again, this is infinity down here, right? So this is 2 over infinity. Well, isn't that just 0 again? You all see what we did? First thing we did was we made sure that this radical was written in exponential form so we could make it work with the rest of these. Second thing is we just take the exponents that are lower. The -5 is lower than +1/2. The x to the 0 here is less than x to the first. And then we just simplified it. Get it down to where there's only an x in one place, like this. And then we can plug the x in and get our answer. Don't think too hard about this. I know that some of these feel really weird. This is really one of those things, just dissociate for a second and do the problem and then wake back up when it's done. Let your insides take care of this. Same idea here. Again, follow x is going to infinity. So what is this going to? That goes away and that goes away, right? So we're left with x squared here. 3x down here. Well, what's the square root of x squared? Isn't that just x? Isn't this 3x? So isn't this just going to be 1/3? Now, here's one thing I do want to show you. If this were going to negative infinity, I want to take a second because that would actually look a little bit different, because here's one thing I did technically skip. The even odd rule, even odd exponent does actually mean that we are technically supposed to have absolute values around these. So if this was going to negative infinity like this technically would be negative 1/3 for the answer, right? Because this would go to negative and this would stay positive. So just be aware. I'm not saying this is going to be somewhere, but it came to my mind, so it had to have come to some other person's mind. So just be aware. All right, we got a couple more. Here, this one. Once again, we're going to follow, let's follow our nose. We're going to infinity land, right? So aren't these going to go away? Well, so what is this going to approach? This is, isn't that just limit as x goes to infinity of x minus x? Isn't that 0? Right, x minus x is 0, and then there's no x's left to mess around with, so we have just 0. Again, don't think too hard about these. Once you have this idea of like going to infinity land, getting all the extra pieces out the way, it does help. It does make a difference. All right, let's do another one. All right, now, with these last 4, now we're actually going to be looking at the function and talking about the vertical asymptote. So we know that there's a vertical. I'm just going to do better than that. Let's make actual axes. So if you remember one like this, the vertical asymptote is going to be at 0. The horizontal asymptote is going to be at 0. And so we're looking basically at a function that looks like this. So from a visual perspective, what we're doing is, remember, we're trying to find the limit as x goes to 0 from the left, right? This way. Well, what is the function approaching? What is y approaching? Y is approaching negative infinity. Now, here's the thing that's going to help you if you can't just draw this off the top of your head, which I think most of you should be able to. But if not, here's what you can do. You can say, all right, well, let's figure out what the sign's going to be. It's either going to be infinity or negative infinity if I'm hitting at an asymptote, right? So let's figure that out. Let's do 1 over 6 times negative, because we're coming from the left, so it's a negative, right? You know, or whatever, something small. But you know that this bottom here is going to be negative, right? One over a negative tiny number is negative infinity. Either way is fine. I personally would much rather picture it. I'm a very visual person. And so when I'm doing this, I would much rather physically draw this out so that I can see, hey, where's that limit going? If I can. I can't always, but if I can, I would like to, honestly. But here, if you're not a visual person and you're a more numerical person, do it like this. X is going to be really, 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 really close to 0 on the negative side. So plug in a really, 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 really tiny negative number. And it's going to be just 1 over negative tiny number, right? And that's negative infinity. That's all. So look, same idea, right? Even though, okay, so that 1/3, how does that do anything? It really doesn't. All this does is it changes sort of the curve of the hyperbola that you have. You know, it's still going to be basically the same thing, looking like this for both of them. And so what's happening as I'm going from the right, I'm going up to infinity, right? As I'm coming from the left, this had better be negative infinity. And then from here, it's just a matter of like, okay, so how do I do that numerically? Well, again, put in a positive tiny number right here, and then you're going to get 5 over a little positive tiny number. So it's going to be positive infinity. Put a negative number here that's really, really tiny. 5 over some tiny negative number gives us negative infinity. Again, don't overthink this. Don't overthink this. Don't think too hard about this where you're freaking out, where you're panicking, because you don't have to. Sometimes it's just as easy as closing your eyes and picturing what's going on and working with it visually. If you can't, then just plug in numbers really close to 0 on the side that they want. So with this next one, notice even power squared, right? One thing to be aware of when you've got an even power, they're either both going up or both going down. So let me show you what I mean. Here's my axes. And then it's the asymptote's at 6. So here's your vertical asymptote at 6. Here's your 0 horizontal asymptote. And what you're going to get is something like this. That looks terrible. Let me try that again. Slightly better. You're going to get something that looks like this. And how do we know? It's because if we try like 7, well, then we get like 3, right? We try 5, we get 3. And as we close in, the numbers keep getting bigger and bigger and bigger and bigger and bigger, right? As we approach the asymptote, this is always positive, right? Even if the number that's in here is negative, even if this is negative 50, we square it, that becomes a positive number, right? That's why this always stays positive. This will always hang out above the x-axis because there's no number I could put in for x to make this entire fraction negative, right? So if we look here, so the limit as x goes to 6, well, what is this approaching? This approaches infinity. And again, we would say, since the answer is infinity, this limit diverges to positive infinity. At this asymptote, at this vertical asymptote, they both go upwards towards infinity. So we would say this limit diverges to infinity, positive infinity, right? And it's important we say the word diverges because we're trying to communicate that this limit doesn't have a number associated with it. It doesn't have, like, it doesn't approach 5. It doesn't approach 52. It doesn't approach negative 12. It keeps growing 5 ever, right? It doesn't stop growing. It keeps growing. And so it never gets to a place. It goes towards infinity. It diverges to infinity, positive infinity in this case. All right, that's all there is to that. Again, don't overthink these. Cosecant. Okay. So it does help if you know what cosecant looks like. It's sort of kind of like this, and there's asymptotes in between. I always have trouble remembering where 0 is on this. I know this is the shape, but I don't remember like how it goes from here. Same thing with tangent and cotangent. I know it looks like a water slide, like a repeated water slide. That's what tangent and cotangent sort of look like. One's going down one way, one's going up the other way. One of those is tangent, one of those is cotangent. Off the top of my head, if I was being asked to pick between one of these right now, which one was which, without being able to do any more work, I would not be able to do it. But luckily, we do have our unit circle. How does that help us? Well, first of all, we're looking at negative pi. So we're looking at negative 1 pi, right? Going this way. And then saying from the more negative numbers, right? So the limit is going this way. We know the whole point of this is that this is actually 1 over sine, right? And sine is 0 here. That's why there's an asymptote here. So what we need to know is are we approaching from the positive side or are we approaching from the negative side? And if we look just before 0, this is like positive tiny, right? Well, this is positive. So this is 1 over positive tiny number, which is positive infinity. Again, this diverges to positive infinity. If we were coming from the other way, that would be coming from a negative number. So that would be negative infinity. But we're coming from the more negative numbers going this way, right? Not coming from the more positive numbers going this way.